How's it going, everybody? There's a couple questions that I received via email and some Facebook posts and some LinkedIn issues and stuff like that. So I wanted to cover those so that we could get this IC&D1 series back on track. I've been spending a lot of time in the last week trying to get schoolwork done and stuff like that so that I could focus pretty much the entire summer on getting my CCNP and stuff like that. So basically what we're going to do now is we're going to go section by section and explaining what is a network and why does a network work the way it does and what are the pieces to it and stuff like that. So I'm going to try to be as thorough as I can, but if anybody if anybody feels like they need more than what I'm offering them, feel free to throw something out there. Let me know what it is you would like me to cover, or if you're not getting it, I can reiterate and stuff like that. So what you see on your screen is a picture of a 24 port switch, and what I wanted to do was go over a really simple concept, really simple concept, and that concept is called a VLAN, a virtual LAN. A VLAN, in the most simplest terms, is a network. It is a subnet. It is a broadcast domain. So any of you that are studying for your CCNA, either one of them, the first half or the second half, or the composite, this is something that you will need to know. Let me find my... There it is. The first thing that I'm going to cover is what a VLAN does and how it works, where you can put them, stuff like that. So a VLAN, let me do something real quick here. I'm trying to be lightning fast. So back to where we were at. A couple things that I wanted to cover was a VLAN is a broadcast domain, a VLAN is a subnet, a VLAN is a network range. So you may be like, well, isn't an IP address a network range? Well, yes it is. But a VLAN, because it is a subnet, will have a network range attached to it. It could be you could incorporate the VLAN number somewhere in the subnet itself, like 10.1.10.0, and the 10 and the third octet would be the equivalency of the subnet or the VLAN that you're applying it to. That's usually how I do it so that I can keep on top of it. A VLAN as a network range can span multiple switches and several ports. So you might have another switch. You might have a trunk link. The trunk link here, and what's up with that? Did not mean for that to happen. Let's try that one more time. And then you might have another switch up here, and then that switch comes here, and then there's another trunk port up here, and then there's another VLAN. Another switch there, and then this half of the switch is one VLAN, and this one's another one, and then this switch has got several VLANs in it, and then you might have VLAN 1, 2, 5, 8, so on. So VLANs are how you can logically separate a switch into multiple broadcast domains. So what do I mean by that? Well, what you can do in the operating system of the switch is you can go in here and say, let's say this switch port right here is a trunk port. A trunk port is able to transfer traffic or trunk traffic from one switch to another, and all the VLANs are able to cross that by default. Any VLAN that you configure is going to be able to go across the trunk, unless you go in there and you modify with either the VTP pruning command, where if a switch is not requesting that VLAN information, it won't send it to it, or you can do a trunk allowed list where you'll only allow certain trunks across certain VLANs across the trunk. So you can do that as well. The idea behind the VLAN is so you could take, say, these ports right here are going to be in their own broadcast domain. So this might be the 10.1.10.0/24. Okay, so that might be this range. Now these two guys right here might be the 10.1.11.0/24. You see how that breaks up? All a VLAN does is it logically breaks it up. Logically means it's in the software, nothing hardware. So the beautiful thing about VLANs is they allow you to scale your network. If you have a router like this guy right here that I'm going to draw, you have a router here, then you have a fast Ethernet port right here. That fast Ethernet port plugs into this guy right here, and then what you're able to do is on the router, as long as it's a fast Ethernet or 100 megabit per second port, you can go underneath the port and go FA0/0.10.11.12, and what you're basically doing is you're logically breaking up inside the router each VLAN. And all you're doing, I mean, there's no VLANs on the router, but what you're doing is you're allowing the VLANs to be routed. If you're implementing VLANs on your switches and you don't have what's known as a layer 3 switch, or a switch that has the capability of routing, or you don't have a physical external router where you're trunking information from the trunk port down to the fast Ethernet port of the router, your VLANs won't be able to talk to each other. Like I said, each one is a separate broadcast domain. So with that being said, if you don't have the ability to route your VLANs, don't expect to be able to put your printers in one VLAN and your computer and your end users in another and expect your users to be able to print. It's not going to work. So that's something you'll have to think about as you're going through your studies and your network designs and stuff like that. So for those of you that are advanced users and this is nothing new to you, you're already there, you can either listen to what I have to say or you can move on to the next video. But for those of you that don't know or don't quite get VLANs, VLANs are the best thing that you can use to scale a network. Now, in the CCNA world, and I'm gonna go off on a tangent here, but just for a moment. In the CCNA world, you've got this. You've got a series of switches. So I'm gonna draw some switches here. You got switches. I'm gonna draw two of them here. And I'm gonna draw a router. Okay. This is a router. This is a switch. I am drawing with a mouse, by the way, so. And this is the snipping tool. I just take a picture of something and it allows me to draw on top of it. It's almost like the having a pin pad in front of me, but not quite. So we have a fast Ethernet port here, and we have a fast Ethernet port here. We have a fast Ethernet port here, and fast Ethernet port here. And the same thing on this guy. So basically what we do is we say, this guy plugs into an end user off here, so we have a computer, end user, and we have a computer. Guy's doing his job. Then we have a trunk link to this guy. Okay, that trunk link allows these two switches. There we go. These two switches to talk to each other. Now this trunk link, this port right here, is connected to this port right here. And what that does, it allows these switches to talk to the router. And all you have to do on the router is go underneath the sub interface, that FA0/0, this guy right here, and say what you're going to encapsulate it with. You have to tell it what type of trunking encapsulation you're going to use. There's two of them out there. Cisco proprietary ISL stands for Inter Switch Link, and there's 802.1Q, or .1Q for short. For those of you that aren't familiar with .1Q, this is interoperability, meaning you can have a Juniper switch connected to a Cisco switch. You could have a Netgear switch connected to a Juniper switch. You don't even have to have Cisco involved. If you're using .1Q, it is capable of running just that. A lot of places do .1Q trunking just because of the fact that they don't have to worry about making sure vendor interoperability. So that's going to be something you're going to keep in mind as well. So we have a trunk link, and then we have an edge port. An edge port, all that means is it goes out to an end user, meaning there's not going to be a network behind that port that you're going to have to worry about. This guy connects into the network and it connects to the switch. That's basically how VLANs work. They allow you to take, well actually what I'll do here is I'll draw another port over here. Alright, and this guy is going to be connected off to this guy, and then we got a computer here. And let's say for instance that this guy's in VLAN 10, this guy's in VLAN 11. The only thing that you'll have to worry about when it comes to setting this type of stuff up is where are your VLANs going to be needed. Now this is a CCNA. This is how Cisco wants you to set it up as a CCNA. Okay, as soon as it hits the router, it's done. It stays. Now I should take that back. You could have a branch office here, branch office 1. We're gonna draw a couple windows and front door, and this could be BR1. Then we have BR2. We have branch 2. Some windows and a front door. I'm definitely not an art major, so excuse me. Then we can have a WAN connection going across the internet. Or it could be a fiber connection, or it could be a wireless connection. Anything that will support trunking. That the information can go across the network. You are going to be able to route your VLANs that way. Do I recommend that? No, I don't. What I would recommend doing, because then that's just extra overhead, that's more processor power on the router. I never recommend routing your VLANs between buildings, because then if something goes down, and let's say for instance branch 2 is dependent on the WAN connection to branch 1 for its printing, because basically what you could do is if you have a WAN connection, you have this WAN right here. If this WAN is providing you all of your services, and let's say this WAN gets cut, okay, and in order for a user over here to print something out of the printer, that just looks weird. If you have it dependent to where it's got to go to branch 1 to hit the router sends the information back across the WAN up to this guy right here, and it says, okay, print, and this WAN connection goes down, you're dead in the water. So Cisco came out with this really cool technique called local VLANs, and I'll explain what those are in just as soon as I get this all erased off here. A local VLAN kind of sounds what it means. You have a branch office, and a branch office. Okay, what you do is you have either a router, you got a router here, and you have your switches. Draw some switches. Then we have another router over here at another branch office, and you have some switches and going across, and then you have a WAN connection going across that's connecting the two buildings together. And what you're going to do for the WAN connection is you're going to advertise some sort of summarized routing information, meaning you're going to send it a aggregate route or a group of routes all at one time. So instead of a slash 24 like these guys, you might send it a slash 23 to encompass these two. Does that make sense? Because the minute you get a slash 24, that's 254 users, right? Of course it is. You go 2 slash 24s, that's 254, and 254 equals 508. Now that's actual end users. That doesn't include the base network address or anything like that. So what you would end up doing is you would advertise a slash 23 in your routing to the other building, and what that would do, instead of sending this route and this route, it would send the 10.1. 10/23. Does that make sense? Because what that would do is 10 and 11 might be in the same range. Does that make sense? I hope it does. There's a video up on YouTube that covers route summarization, but I just wanted to kind of give you an idea of how you would want to send the information across the wire. When you're dealing with what they call local VLAN, so you have branch 1 and you got branch 2, your local VLANs are just going to be that. They're going to be in blocks, and the VLANs that are here will be completely separate from the VLANs that are over here. So this guy might have 10, 20, and 30. This guy is going to have the same, 10, 20, 30. But the IP address ranges might be different, or they may be the same. It just depends on what you're advertising. So if you're trying to get information outbound from here to here, it's going to go across the WAN and come in here, and he's going to know what to do with that. Simply for the fact that when you're advertising your routes in here, you're going to advertise into whatever subnets are here. But here's the kicker. Like I said, the VLANs that are here might have the same IP addresses as these guys. That's going to be okay for locally significant. Now, I never recommend having the same subnet ranges at the same buildings. You can do it as long as these guys never talk to each other. Because what will end up happening is if these guys have the same IP address ranges, then what will end up happening is this guy actually wants to send information to this guy. What will end up happening is it'll never leave the building because routers always route on shortest path first. Well, what does that mean? Well, that means that if it's not going to cross a WAN connection to hit this route when it thinks this route is right here. Does that make sense? So what you're going to end up doing is when you do your subnetting, you're going to take it and you're going to give each branch office its own subnet range, whether it be /27 by /22, depending on how many users you need per subnet, or I'm sorry, per branch. That'll determine which subnets you end up using. So if you have a lot of users, you're going to need a bigger address block to allocate IP addresses to each other. So, like I said, if you could, if you're never going to advertise information between the two, you could do that. But I never recommend doing that, especially most businesses, they want their branches to be able to talk to each other. So this guy might be the 10.65 or .10. Whatever /24 for that range. This guy might be the 10.65.11. Just depends on how you want to set it up. That's all I'm saying. I'm not going to give explicit details on how to subnet because I've already explained subnetting and how it works, and but I can go over. I can go back over that. It's not a big deal. If you guys would like, that's something I can definitely do. But that's how VLANs work. Now, at the CCNP level, this is what you're going to deal with. You're going to deal with address blocks, and if you're at the CCNP or the CCIE level, you should pretty much be able to subnet at the top of your head. You shouldn't have to sit down and think about it unless you get a specific range, and you're supposed to summarize that, and you got to figure out what the best subnet bit is. Sorry about the wait, folks. I got a phone call and had to help somebody out with something. And I don't like getting interrupted because I lose my train of thought. But basically, the last thing I wanted to cover here before I kill this video is I've covered a broadcast domain, a subnet, a network range that can span multiple switches and several ports. Because you can have VLAN 10 here, you can have VLAN 20 here, you can have VLAN 17 here, VLAN 10 here, 17 here, 20 here. It all depends on where you want to put them. And it's really easy to apply them. You just type in the switch port access and VLAN and whatever VLAN you want to put on that port. As long as it's been created, you should be fine. It just depends on the vendor. In most cases, Cisco, when you implement it, automatically creates it as well. So that's the only thing you really have to worry about. The last thing is a collision domain. What is a collision domain, and how does it work? Well, back in the day, you used to have a thing called a hub, and a hub was just basically it's a layer 1 device that just regenerates electrical signal, and so as information comes from the switch to the hub into this port, the hub sends that information back out to another device, maybe an access point or an end user, and what ends up happening is there might be 30 ports on this hub, but every port on this hub is a part of the same collision domain. It's also a part of the same broadcast domain. So what ends up happening is if a user 1, this computer right here, sends information inbound to the switch, or to the hub, and so does this guy at the same time, their incoming frames will collide with each other. There's no way for the hub to separate the collision domains in order for multiple users to send and receive traffic at the same time. A switch differs in that regard because of the fact that it is able to do MAC address mappings. What do I mean by that? A MAC address mapping is real simple. What it does is it works like this. You have a thing called a CAM table, or Content Addressable Memory. And what that does is every time a user plugs into a port, okay, so this guy, user plugs in, and then, he's on his computer, the MAC address of the network card here gets saved. It gets learned on this port right here, and then it says port 1, and it's going to be MAC address X, okay, and this is MAC address X right here. And then because it knows what port it came from, it knows that if this guy right here sends a frame in here and it's destined for this guy, he already knows the MAC address where to send it. So this guy knows port 2 is going to be Y. So when port Y sends a frame inbound to the switch doesn't have to broadcast it out all ports because it knows that the destination MAC address is is X, and that is attached to port 1. So as the information comes in here, the switch takes it and sends it layer 2, checks the MAC address table, the CAM table, and ships it right back out port 1 to this guy. Does that make sense? Because of the fact that it knows where to send it, it's able to make every individual port on a switch a collision domain. So if you have a 48 port switch, you have a 48 port collision domain. So, or 48 individual collision domains, I should say. So, with that being said, what happens if you get this guy sends a frame in here, but there's no the destination is unknown? Well, that's very simple. The switch, if it doesn't know where to send it, it sends it out everything. So every port gets it until it finds out where it's got to go. Now it'll send it out this one, and then if it's attached to, say, this switch, all ports on this guy will get it. And if this guy doesn't have it, it'll send it up to this guy, and this guy will send it out. It'll keep going until it finds out where it's got to go. And if it doesn't know where to go, you'll get it just won't work. It'll die off. So if once it learns where the port is, it'll map it, and then it'll add it to its CAM table. Now, those of you that know a little bit more about this networking thing than other people, you will know that there is some nuances with the CAM table. Meaning, once you learn it, after 5 minutes, it ages out of the CAM table if it's not continuously used, so that the CAM table is not overloaded. Now, what happens if the CAM table, let's say for instance this CAM table only had the ability to hold 10 entries, or 10 MAC addresses. So this thing's got 10 MAC addresses in it. What happens when the 11th one tries to come in? You over in the corner, you're almost there. I'm just kidding. There's actually nobody in front of me. But what ends up happening is if the cam table is full, it will start broadcasting any additional information. If it knows where to go, it'll still send it. But and by the way, the oldest gets aged out if it's not in use. If it's not in use, it gets aged out. If it knows about it, it'll still send it where it's got to go. But the minute you overload it to where it can't hold any more in, it'll start broadcasting it out because it doesn't know where to send it. So if you send a multicast or you send a frame inbound to the switch and the destination is unknown, it'll broadcast it out all of them. This is pretty popular layer 2 attack called the denial of service, meaning you deny service to everybody. So it is very, very easy to mitigate because if you don't want anybody to be able to access your network that shouldn't be accessing your network, you throw any unused ports, you throw them into what they call a black hole VLAN. That could be any VLAN number you want to choose that's not being used. So if you create, say, VLAN 100, and then you throw any unused VLANs at that moment into VLAN 100 as switchport access VLAN 100, somebody plugs into that. There's no routing for it because you don't go into the router or you don't create a switch virtual interface for that particular VLAN number. And so basically all it does is Windows or Linux, it generates a locally significant IP address, typically a loopback IP, or if you're Windows 169.254, and that's all it gets. Doesn't get any more. So that's the nice thing about setting it up. Now, are there any additional caveats? Well, yeah, there is. There's actually quite a few. There's other things you can do to guarantee what happens in layer 2, and you can set up static MAC address mappings, stuff like that. That's way beyond anything the CCNA covers right now. What you need to know is what's on your screen. You don't need to know any additional information. The idea behind getting a solid understanding of how switches work is understanding the fundamentals behind it. Now, I struggled a little bit when I first started getting into it because of the fact that I didn't quite grasp all of this. If you are new to the CCNA or the CCENT exams, I highly recommend you go in and you study the the Network Plus. If you study the Network Plus, that will give you a very sound foundation, a very solid foundation to the networking industry as a whole. It'll teach you what a switch does, it'll teach you what a router does, the different types of cabling, layer 1, layer 2, layer 3, and layer 7. Well, there is layer 5. It'll teach you all 7 layers of the OSI model, and it'll break down each one of them. It's a vendor-neutral certification, meaning that it doesn't focus on any particular vendor. It just focuses on networking as a generality. So that's what I did when I first started getting into it. I have not earned the certification because I haven't tested for it. But speaking of which, I think I need to go download a practice test so that I can actually study for it. Because I plan on going after that certification as well. Because that's, it's general information. I feel like being a CCNA, I should be able to go in there and knock out the Network Plus pretty easily. So if you're well-rounded in the network industry already, like maybe you have a CCENT or you have a CCNA and you're just looking for a refresher course, this is all information you should already know. Now, I will go ahead and I'll throw out a little thing with this. There's always going to be a layer 3 to layer 2 mapping, or ARP. And ARP just basically means you know the layer 3 or the IP address, the logical IP address, but you need to know the layer 2 address as well. In order for you to transmit information via IP, you need to have both layer 2 and layer 3. So when it comes to frame relay, you need to know the DELC. If it's ATM, you need to know the VPI VCI pair. I don't know ATM, so I'm not even going to begin to go there. If you MPLS, you need to know the label. So that's basic. That's the basic information you need to know. That's it. I mean, I could go off the deep end and really get into the granularity of how switching really works, the different types of switching, and that route. But I really don't think you guys need to know that. Well, at the CCENT level, I would say. But I will cover it eventually. I wanted to cover what a VLAN was. This is not how a switch switches. I've already covered a video like that. So that's basically where it sits. So for those of you that are looking for a really in-depth look at it, that's pretty much it. I mean, switches are pretty straightforward. They forward frames in layer 2. Some switches know how to route because they have a routing upgrade inside of them, so they have a router built in, and they're able to route packets, and you're able to use that. But beyond that, that's all you really need to know. I mean, conceptually, it's pretty straightforward. So if you have any questions, feel free to give me a shout. Comment on my YouTube channel. I check it almost every day, at least twice a day, and go from there. I hope this has been informative for you, and I would like to thank you for viewing.